Hello everyone, I'm Noemi Mauro from the University of Torino, and today I'm going to present a faceted exploration model of cultural heritage. The richness of cultural heritage exposes tourists to an information overload which makes it difficult to practically visit within a tour. In general, we can see maps as a representation of shared data for user collaboration, for example, when they have to organize a tour. We can also consider maps with a long-lasting nature being useful before, during, and after the experience. So, for example, they can contain artistic information, geographic, and logistic one. However, people traveling together might be interested in different subsets of the same items based on their characteristic. So we have to offer a tool to the user to filter the data based on their interests. This work is framed in the OntoMap project. The goal of the OntoMap project is to support cartographic information sharing and visualization in local community. OntoMap allows the consultation of spatial data, the integration of public open data, the creation of interactive maps, and the crowdsourcing of content. OntoMap is an ontological layer that is used to integrate heterogeneous data and manage them as linked data. For example, it contains the mappings with the OpenStreetMap tags. It contains the definition of data categories and facets, and is also useful to specify graphical details for map visualization. For example, it contains categories, colors, and icons. Here we can see the OntoMap web application. On the left side, we can see that there are the graphical widgets for the searched categories. Then we have markers on the map that are represented with icons that graphically represent data categories. And then in the right side of the web interface, we have the details of an item. The problem that we are going to face is that maps can be really cluttered, containing a lot of information, as you can see in the picture. So our goal is to offer a tool that allows the creation of custom maps that can be adapted to reflect temporary information goals while persistently storing the shared data in order to preserve the overall collaboration context. So we want to support interactive coarse-grained and fine-grained focusing of geographic maps via interactive widget. So we have two proposals. The first one concerns an interactive representation of the search context for multi-category projection based on widget that supports data visualization, faceted exploration, category-based information hiding, and transparency of results. And then the second proposal concerns a function to define the exploration cost of facets based on the suggestion of efficient facets for data exploration in sparse and noisy datasets. Here I'm going to present the two widgets that we investigated. The first one concerns the checkboxes that are the typical tool that we can find the e-commerce and booking website. So on the left side, we have the place of worship categories with its attributes. So for example, religion. And then with the checkboxes, we can filter the values. In this case, we selected Christian and Muslim. Then when we select a specific point of interest that have been filtered, we will have highlighted in the details the values that we selected. The second widget is represented by the sandbars. The sandbars is designed with these two circles. The one in the middle represents the attributes, while on the second level we have the values corresponding to the attributes. So in this way, we are able to see all the attributes together, and we are able to have an overview of all the characteristics of the selected category. After that, we define an exploration cost function in order to define which facet should be displayed on the user interface, and also to rank them according to their ability to filter the information items. So we first did a pre-filtering phase in order to exclude the facets that appear very rarely in the results. And then we defined the exploration cost function that is computed by taking into account the entropy and dividing it with the mean cardinality of the facets. We couldn't use functions that were present in the literature because all these functions were giving priorities to balanced facets. However, when we deal with open data, we often have unbalanced facets, but that they are still able to filter the information space. For example, if we take into account the cuisine facet, with our function, it will be highlighted with a yellow color, so it will be ranked in the middle place of the list. While if we take into account one of the functions present in the literature, the facet cuisine will be highlighted in red, and so probably it will not be displayed. For the validation of the visualization model, we asked the user to solve two map learning tasks. The tasks were question answering using checkboxes and sandbars, and for each task we asked the participant to answer to two questions. The first question was like how many category names, for example churches, have the characteristic X, for example that are accessible with wheelchairs, are visualized within the orange line in the map. And the second question was like find the category names, so for example restaurants having characteristic X, so for example Chinese, within the orange line in the map and list them. For what concerns the experimental setting, it was within subject design. We investigated the evaluation of the two types of information exploration widget. We counterbalance the task in order to minimize the effect of practice and fatigue, and we asked the participant to sign a privacy consensus according to the GDPR. We measure objective and subjective measure. For what concerns the objective measure, we measure the execution time and the percentage of current answers. And for what concerns the subjective measure, we ask the user to fill a questionnaire at the end of each task and a post-test questionnaire at the end of the user study to measure the user experience. The duration time of the test was about 30 minutes. And we investigated the familiarity, the helpfulness, the effort saving, the ease of use, and the novelty of the widget. We also asked the user to answer to some free text questions, in which we asked if they had difficulties, which widget they will use or avoid in the future, and if it was useful for them to combine transparency sliders with other widgets. We interviewed 62 participants. The majority of them had an high education level. They often use the online maps, and they mostly have a scientific and technical background, but some of them also had other backgrounds, and they are also often using e-commerce platforms. The results show that the participants correctly answered to all the questions and that the sandbars had the lowest execution time. For what concerns the user experience, the best widget for what concerns the familiarity was the checkboxes. Both of them were helpful and effort-saving. Users said that checkboxes has a better ease of use, while the more novel widget was the sandbars. In the future, they say that they will use again the sandbars. So in general, we can say that the sandbars is a good model to compactly visualize all the facets and value of a data category, and it also minimizes the vertical expansion of the sidebar with respect to the checkboxes. We notice that there is a frequent usage patterns, so users often combine coarse-grained information hiding with the transparency slider with fine-grained faceted selection using checkboxes on sandbars. So they first reduce the complexity of the map by hiding all the items belonging to the categories that they are not of interest, and then they focus on the details of the categories of interest in checkboxes or sandbars. As future work, we plan to adapt the facet suggestion to the user preferences in order to personalize the navigation of the information space. We plan to add support to collaborative work in sync. We will investigate this aspect in further experiments, and we also plan to adapt and test our model in mobile setting and possibly using small displays such as those of mobile phones. Thank you for your attention.